Hey, what's going on guys? Tanmaya for Simple Snippets, and today's video tutorial is going to be a practical program with the question as follows. Check if the year is leap year or not. So we are going to be writing a program to check if the entered year is a leap year or not in Java programming. So this is a quick short practical video, and if you're a beginner, I'm pretty sure you'll be coming across this program in your practicals or in your exams. So leap year program, checking of leap year program is pretty famous and always asked. So make sure you watch this video till the end so that you understand it properly, and I would request that you program along with me to get the best practice. And this leap year program might sound easy, but it's not pretty straightforward. So with that being said, let's start off with the programming part. So let's first read out what the rules are for a leap year. By the way, a leap year is a year wherein the number of days in that year is 366 and not 365. Typically, a normal year has 365 days. However, a leap year has one day extra, that is 366. That's why we have 29th of February. Usually February has 28 days, but a leap year has a February 29th. And this happens every 4 years, and I'm not going to get into the details and astrology part of how a leap year occurs. But let's see the rules in general. So every year that is exactly divisible by 4 is a leap year, except for years that are exactly divisible by 100, but the centurial years are leap years if they are exactly divisible by 400. Okay, now this was a big statement and it sounds a little complicated because it is a mixture of multiple conditions. So here are some examples. So if the year is 2400, it's a leap year. The reason we have condition 1 satisfied, and I'll get to those conditions. In fact, let's start off with the conditions first. So programmatically or logically, there are two conditions that need to be satisfied for a year to be a leap year. So the first condition is any year that is divisible by 400 is definitely a leap year. So if any of the year is directly divisible or exactly divisible by 400, and by exactly divisible I mean that the remainder is 0 and not some fractional quotient that you are getting, it has to be 0. So that kind of year is a leap year. For example, 2000, 2400, 2800 and so on. So this was the first condition. The second condition is a composite condition, which means it has two conditions combined together with a logical AND operation. So the second condition is if the year is divisible by 4 and it is not divisible by 100, then it is a leap year. So both of these individual conditions has to be true for the whole composite condition to be true and for the year to be a leap year. So let's see the examples. So if the year is 2400, it is a leap year because condition 1 is satisfied. 2400 is directly divisible by 400, right? So this first condition is satisfied, so it's a leap year. But if the year is 2200, it's not a leap year. The reason is that condition 2 is not satisfied. So you can see the number is divisible by 4, correct? 2200 is exactly divisible by 4, but it should not be divisible by 100. It should not be divisible. But you can see 2200 divided by 100 would be 22, right? Which means that 2200 will be divisible by 100 also. And this is not what we want. We want a number which is not divisible by 100 and which is divisible by 4. Only then it would be a leap year. So let's see case number 3 or example 3, 2020. Now 2020 is a leap year. Why? Because condition 2 is satisfied. Of course 2020 cannot be divisible by 400. That's true. But then this condition is satisfied. It is divisible by 4. Yes. 2020 is exactly divisible by 4. But you can see it is not divisible by 100. If I divide 2020 by 100, I would get 20.2. So I'll get a fractional part, which means that it is not directly divisible by 100. So that's why this condition is true. So this is the crux that we are going to use and perform the programming. And you can see that it's not really straightforward here. There is no single simple condition, but it is two different conditions, and even the condition 2 has two composite or two small conditions. So now keeping this logic in mind, let's start off with the programming part. Open up your NetBeans ID and create a project, and I would recommend that you program along with me for the best practice. We will declare a variable int year. Let's take the examples from the notepad itself. We will assign year as 2400. Now let's see the condition, that is if any year is divisible by 400, it is definitely a leap year. So let's start off with if year mod 400 equal to 0. Now remember, to check for divisibility, we use modulo operator because we want to check for the remainder and not the quotient. When 2400 is divided by 400, we will get the remainder as 0, right? So we want the remainder to be checked. So that's why we use the modulo operator and not the division operator. Okay, so inside the if block, I will say system.out.println leap year because this was the first condition, right? Now let's see the second condition as else if So let me just read the condition. The condition was if divisible by 4. So I'll say if year mod 4 equal to 0, and the next part is and not divisible by 100. So we have to use a logical AND operator. So the double AND stands for logical AND operation, and then again you have to say year mod 100 not equal to 0. So this is the not equal to sign. You have to use exclamation and then equal to, and this is a double equal to which checks for equality, and not equal to is exactly opposite to double equal to. So the reason why we are using an AND operation is because we want both these conditions to be true, and only then the entire block will be true, and then the else if part will be executed. So again, this is condition 2 for being a leap year. So these are two different conditions. They do not overlap. That is, this condition is separate and this condition is separate. Either of the two conditions need to be true for a leap year. And if both of them are false, then in the else part we can directly say that not a leap year. Let's save this and let's try to run this program. Now I'm hard coding the value. I'm not taking it from the user, but you can use scanner variable to take the input. If we run this, you can see our program is running. So there you go. We got the output as leap year, which means 2400 is a leap year. So this is what the example was. Let's try with 2200. So I'll say 2200 over here. Save this and run this. It should be not a leap year. And there you go. You got not a leap year. Now I'm going to try for 2020. So the else if block should be executed. And it should print leap year. Let me run this. So there you go. We got leap year, which means both the conditions are working fine. And our program is running successfully. And we've programmed it properly with the proper logic. So that's it for this program part. I will share this entire rules and details in the description of this video, so you can check it out. And also if you want to know more about why leap year happens, you can just Google it out. You'll get a lot of details and a lot of information. But if you want the logic, this is the logic. You can see if else. So pretty much in any programming language, you have to implement this logic itself. And this will hold true in almost all general programming languages. So that's it for this video, guys. I hope you understood how to write a program to check for a number being leap year or not, for a year to be a leap year or not, and I hope you got the logic. If you like this video, give it a thumbs up, share it with your friends, and if you haven't yet subscribed to this channel, make sure you subscribe so that you get notified whenever I upload a new video tutorial. So I'll talk to you guys in the next video. Peace.